This conference will now be recorded.
That's great. So, my dear friends, this session is about a technical introduction to ACI. As you know, this is Cisco's product. This is one of our data center solution. This data center solution is nothing but this solution as per industry is known as SDN solution. SDN stands for software defined networking, and I am sure all of you know it very well. Just like Sd Van, software defined wide area network. Today, everything is coming onto the software platform. Software platform doesn't mean that entirely it is software, right? We do have hardware. Hardware forms the base of it. So this ACI is nothing but it is the Cisco's solution, Cisco's version of software defined networking. And my dear friend, let me tell you, in today's world, right, in today's data center, approximately, right, 80% of data centers, they have either moved to ACI or they are moving over to ACI solution. I will say no need to argue on this. Cisco is the top notch in terms of software defined networking solution today. So this is what we are going to do, and I'm sure I need not tell more about it, about justifying that how important today Cisco ACI is in terms of data center solution. So in this beautiful journey, what we are going to study about, we are going to look at into the theory part of what is ACI, why ACI, what makes the ACI, that means the physical topology. This physical topology is absolutely different from that of our traditional topology, which we are using and call it to be as a three-tier architecture. And well, you know what? I will say when it comes to the topology, old is gold. Okay, old is gold. So this topology, what we are going to see, we are going to prove that the old 1938, right? Old. Same topology is now getting used. So we will be discussing about it. What different constitute our ACI building block? What is APIC, which is a controller in ACI? What are various protocols? APIC maintenance, you know, this is pretty important for us to understand in case if any of our controller goes into a faulty state, how can we repair it how before? Because it is very important that we need to make sure that all our controllers, they are in an up state before we go ahead to do the configuration, and then we come over to our first very step. So we will be building up our fabric, our complete ACI fabric. We will be talking about, you know what, it is very vast. So in one single hour, with your questions and your doubts, I will not be able to cover up everything. So we'll be giving you just a glimpse of it. What we are going to talk about, we will be talking about ACI control plane protocols. We will be discussing about various different labs, and of course, where we are going to do the labs, we will be talking about that as well. Okay, so we have our another advanced component in ACI, which is called ACI Multi-Pod. We will be talking about it. And you know what? I have removed one thing, which I will like you guys to request. If you really want to understand and learn, that is nothing but that is called multi-site deployment of our ACI besides learning multi-pod deployment of ACI. Okay, one more time, once again, dear friends, please do feel absolutely free if you have any question in between. It's not that I have to finish my session, only then you can ask. It's absolutely not only with regards to demo, but also with regards to our ongoing classes, our live classes. You can ask any time, any question of your choice, right? It will be at my discretion, yes, to park or answer the question immediately, but your questions will be answered. So I understand that our other dear friends, they are also joining. One more time, I would like to welcome all of you guys, and those especially who have just joined. So that's only need, that's the reason I need to repeat that. Yes, feel absolutely free if you have any question. So we are going to talk about what is ACI, why ACI, ACI physical topology, ACI building block, what is our APIC, that is the controller, what are various protocols, our APIC protocols, what is APIC maintenance, etc., etc., etc. Okay. So what is ACI? ACI, which stands for, A stands for application, C stands for centric, and I stands for infrastructure. Cisco has purposely specified this particular name. Why? Because Cisco says that this particular solution is a solution for our cloud infrastructure, which means what is the main focus of the cloud? The main focus of the cloud is to provide the application availability anywhere, anytime. So Cisco thought of specifying software-defined networking solution as application-centric infrastructure solution, which doesn't mean that our centricity is not on network. Dear friends, there is no harm if you call this to be as a network-centric infrastructure as well. You know what? This means there are two different deployment ways of our ACI. One deployment is called application centric, other deployment is called network centric. Network centric deployment says that we are just providing the transport infrastructure to our applications. Our application infrastructure may be hosted in some other virtualization platform. For example, it could be your VMware solution where the applications are centralized over there. So anyway, Cisco SDN solution says that we are capable enough to let you focus on your application. We will provide the transport infrastructure and the connectivity to your application. Now, this infrastructure is entertained in two-dimensional way. One dimensional is the physical, and other dimension is the logical. The physical is nothing but where our physical specific switches are involved. And what are those switches? Those switches are called Nexus 9000 switches. And logical provides us a special topology, not the physical topology, but the logical topology, which you can say the container based. Container, please don't confuse it with Kubernetes. We are going to say that there are containers. Containers in terms of, say, boxes. For example, this, we say this, and then we say this and this. Kind of this particular topology. So what we need to understand in ACI, we need to understand this physical topology. We need to understand the logical arrangement of these physical devices. When we say logical arrangement of it, this means we are talking about and in terms of our application centric infrastructure, right? Application centricity we look at into. I hope I'm able to make a vague picture in terms of it, which is nothing but which is focused towards our mission. So what is ACI? As per the terminology, it says application centric infrastructure. Then a big question comes. Why do we need ACI? And answer is very, very confusing. It says ACI is SDN. We want application agility. We want multi-tenancy. We want micro-segmentation. We want ease in deployment. We want traffic optimization. We want real-time visibility and application health score. So many things are involved when it comes to ACI. Guys, just a second. I hope this all makes sense. And in case if it doesn't make sense, then at least it creates confusion. And confusion is not a confusion. Confusion is basically the questions which definitely should pop up in our minds. So why do we want ACI? We want ACI for the purpose of multi-tenancy, which means that in this particular course, you will understand what is multi-tenancy, right? In case if you have done with the VXLAN, our first introduction to multi-tenancy happens in VXLAN, wherein we understand how the same VLAN ID spread across two tenants, they can still talk to each other. That's VXLAN. We will be studying about the micro-segmentation as well. ACI provides us the most important thing is ease of deployment. You know what this means? So many devices, we need not go into each and individual device to do the configuration. ACI abstain ourselves from box by box approach. That is, I'm sorry, there is no box by box approach. ACI provides ease of deployment by helping us to deploy our humongous configuration from one single device called controller. We are going to talk about it. No marketing. Truly, this particular statement, all whatever is being provided to us, it looks to me personally as well, absolute marketing, but no marketing. But we need to know how ACI simplifies network admin's job. And this is what a network operation engineer looks like. He gets so many tickets on his desk. He has to look at into so many requests, and he simply gets overburdened with the tasks. So ACI is meant to simplify network operations job by providing a simple architecture, by providing simplest way of configuring the architecture. What does ACI typical now? You know what? He is a network operation engineer. He has in his mind one simple thing, that is when it comes to network architecture, he knows that this is a three-tier architecture. Let me tell you, this guy wearing tie and all, suited booted, but and he calls himself as ACI expert, but he is trying to confuse this guy by saying, hey dude, I have three-tier application architecture. It is wrong according to me. If you try to directly say to a network operation engineer that my ACI is a three-tier application architecture, because it will be very confusing. Simply saying that I do focus my attention on web application, app application, and database application, and how the communication of the endpoints in these application happens. This is what I do, right? Endpoints. It is inappropriate to talk about ACI in this particular way. Of course, this guy A typical network engineer, he will simply get confused. So that is, we need to move ourselves from that confusion. Comparing ACI and traditional network management. So when it comes to our traditional network configuration management, this is how we do it. That is, first of all, we go to the configure terminal, and then from there go into the interface, configure the interface. If you have got Nexus devices, then you have to trigger in the feature to use it, and blah blah blah. All this is nothing but, this is all CLI based, command line interface based. ACI abstain itself from box by box approach, and thus from CLI way of configuring our traditional networking, where it says, I can hear some sound. Oh, it's just not the noise. If you have unmuted yourself, my dear friend, please let me know. Question. Else you can mute yourself.
Hi. Hello?
Yes, Sequara. You have any question?
Yeah, I have one question, please. But I'm getting
Please,
a lot
go
of disturbance from where I'm getting. Can you mute it?
Okay. At
Yes.
this time, two dear friends of mine, they're talking. So, all right. Okay. 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 Yeah, go ahead, Abdul.
Yeah. Myself, Abdul Kalim. I'm residing in the KSA. My question is, what is different between the ACI and SD-WAN? Because I have one confusion between the ACI and SD-WAN.
Okay.
What is the
Very good
traditional?
question.
What is the traditional network that's supposed for the ACI and SD-WAN?
Okay. First of all, very good question, Abdul. Thank you so much for asking this question. What is the difference between, let me get, you know what, a blank slide to talk about it. And here it is. Your question is, what is the difference between SD-WAN and ACI? ACI is nothing but it is called SDN. First and foremost, if you talk about from Cisco's point of view, and in which particular stream we learn about, SD-WAN comes under your enterprise infrastructure, which is nothing but the new name given to routing and switching. This ACI is part of your data center. SD-WAN is nothing but it is a software defined wide area networking, of course, where the configurations are going to be controller based. Same happens over here. In case of SD-WAN, this SD-WAN talks about the wide area network configuration. This ACI talks about the configuration inside the data center, which means that in case if your data center wants to exit certain traffic out, you know what, then it is ACI plus SD-WAN. For taking your data center traffic outside from, say, if you have an enterprise infrastructure, and in case of enterprise infrastructure, you have your data center and you want the SD-WAN to take your traffic out, you can use software defined wide area networking, which means your WAN devices will be configured on the basis of controllers. Right? This is just a high level understanding. Then you need to deep dive into SD-WAN and understand what is vManage, what is vController, and so many new terminologies, virtual manager and all. Does it make a little sense, Abdul?
Yeah, clear. Thank you.
In fact, we are not going to talk about SD-WAN over here. We are going to focus our attention on ACI, right, which is a data center technology. SD-WAN is an enterprise infrastructure technology focused towards taking our traffic outside. Well, having SD-WAN with ACI is not mandatory. That's another important point. It is an option. If you wish to add SD-WAN along with ACI, then it's okay. Otherwise, it's not at all mandatory to attach SD-WAN with ACI. And we normally don't do it. And we will not be talking about that as well. Okay. So we have seen, all right, we were talking about this traditional networking. Traditional networking talks about what? 3 layers. The topmost layer is called core. Then middle layer is called distribution layer. And then we have our access layer. This is what is the architecture. And in case of our traditional networking, the major significant part is there is an overall connectivity like this. The triangular connectivity between the devices, or a circular connectivity between the devices. And by the virtue of this connectivity, what do we see is a loop. And in order to avoid this particular loop, traditional networking says I have to use the spanning tree protocol. And spanning tree protocol says in order to avoid this particular loop, I'm going to block one of your port. This blocking of one of the port is very much disappointing. Why? Because when a customer purchases a switch, he pays for each and every individual port. So traditional networking, what it says, that you need to block one of the port in order to avoid the loop, L2 loop. So, well, this particular traditional connectivity is not the connectivity we should appreciate. And that's what we say as old fashioned, but there is another way of doing the things better, and that is called ACI. ACI is a new B. Now it has become a very old B. Comparing traditional networking, it is called as a new one. But when something new comes, it comes with many new terminologies. And whenever new terminologies come, it is our holistic responsibility to understand the new terminologies in analogy with the old terminologies. So guys, if you really want to understand ACI, it is very, very important. You really need to understand ACI, a new thing, but in an old fashioned way, by establishing the analogy. That's what we are going to do. I will not be able to teach you, learn you, make you understand ACI unless and until I establish its concurrence with the old technologies, what we have been practicing and preaching on for so many years. That's what we are going to do. This is how ACI physical topology looks like. I'm sure you must have seen it. This is not at all new for you. This topology says that we do have 2 layers where our data plane actually works. One layer is our spine layer, and another layer is called leaf layer. This topology was first time developed by Mr. Edmund in the year 1938 formalized in the year 1953 by Charles Claus, and now Cisco is using this particular topology. Not only Cisco, the SDN is using this particular topology. If we look at into this topology and compare it with the previous one, we can see, my dear friends, there is no east to west connectivity, neither between the spine switches, no such. There is no east to west connectivity between leaf switches as well. What connectivity we do have between these two layers is nothing but this is our north to south connectivity, right? So it's altogether our north to south connectivity, which we do have over here in case of our ACI. This avoids or this bypasses or keeps spanning tree protocol at its bay, which doesn't mean that spanning tree protocol is not available. Spanning tree protocol is available, but by the virtue of the physical connectivity, spanning tree protocol remains in its own bay and do not make any of the port to go in a blocking state. Now, then in this particular topology, you may have, good number of your spine switches. You may have, say, tens and hundreds of your spine switches, leaf switches. This topology prohibits us or saves us from box by box approach of configuration. So the configuration comes as a responsibility with these guys called APIC controllers. So the management layer is different. This is holistically used for the purpose of management. Over here, what do we see is we see our control plane and our data plane. This topology says you please deploy minimum of 3 controllers for the redundancy, for the resiliency, and in case if you don't have 3 controllers in production environment, we will keep on sending you a continuous warning message. Lab environment, single controller is fine, but production environment, you should have at least 3 controllers, right, in ACI. Well, we are going to talk in detail why do we need 3 controllers, but for that, you need to have a basic idea of RAID mechanism, right? We will be talking about that, why 3 controllers. So, well, in the detailed session, you are going to get answer to multiple why questions. So, what and why? What are these? And what are these? That is, what are spine switches and what are our various leaf switches? What are their models? What are their capabilities? And why they are placed over there? So there are different models. Well, I will tell you in detail about Nexus 9500 series switches, 9300 series switches, what are the different models in 9500 series switches, and what is the most beautiful feature in 9500 series switches, right? Those dear friends of us, those who have already attended Nexus hardware session, we have already discussed, and we do discuss 9500 series switches. Of course, they're the fabric switches in proper and thorough detail, which I will be discussing in full-fledged session. So you can make a note of it. In our full-fledged session, we are going to look at into Nexus 9500, its hardware architecture. Okay, ACI building blocks, and as I have given you a glimpse that what we have in ACI, of course, spine and leaf switches, and we have our controllers. So when it comes to spine and leaf switches, we have got our spine switches available with different models. So the models which you can see over here, these are the models of our ACI 9500 series switches, 9504, 9508, 9516. These switches are the switches which are deployed only at the spine position. Yes, I would request you to request me to show you how these switches will look like, what are the components in front, behind, and inside, and how the chassis looks like. Do we have, you should have a question, do we have something called backplane? Where is its backplane? You should have a question about its midplane. You know why I'm asking all these? Because it is for the first time that Cisco revealed an empty box to us, telling, if you want to see my box, this is my box, a blank box. So various components are inserted into this box in the form of modules. So for example, in this, what we do get, we get line cards, we get fabric modules, we get soup engines, we get system controllers. You know what, dear friends, it's very, very, very important to know about each and every component. Besides it, we do have our fan supplies and we do have our power units, right? The placement of these devices is very important. The individual function and the throughput of this device is very important, and specifically when you are going for bill of quantity or bill of material creation, we should know the throughput of each and every line card. Recently, I came across this while I was presented with the bill of material. I had a critical question about it. I checked and verified, yes, the bill of material provided by Cisco is a legitimate, is a correct bill of material. It is definitely going to come across to you as well. And this is what we will be discussing in thorough detail. We use our 9300 series switches as well for the purpose of spine. In case if we are using 9300 for the purpose of spine, we call them as our baby spine. Otherwise, 9300 series of switches, they are basically for the purpose of deploying them at a leaf position. So predominantly these switches are leaf switches. Guys, please do ask in case if you have any question. All right, I'm taking your silence as acceptance. And besides having our spine and the leaf switches, we have our controller. This controller is nothing but this controller is a server. Probably we know that Cisco is also into the field of manufacturing servers, stepped into this field way back in the year 2009 when Cisco introduced the servers called UCS, Unified Computing System. So this particular server, out of two different major variants called B series and C series. B series are blade servers, C series are rack servers. this is nothing but, this is your Cisco UCS C series server. We will be looking at into its morphology, right? And if you wish to, I'll show you the anatomy of the various internal components of this particular server, how and what are various interfaces in this particular server, which are supposed to be connected to leaf switches, which interfaces are in active state, which interfaces are in active and standby state, and what is all this we will be talking about. The physical topology of our spines and leaf switches, we have already discussed them with, of course, our controllers. APIC, application policy infrastructure controller, is the full form of controllers, and these controllers are supposed to be connected to our leaf switches only. Right, this is we are going to talk about in our detailed session. Because time is running, Cisco 9508, this is just a small attempt to show you that how the switch looks like and how the line card looks like. 9300 leaf switch, you can see, and I would like you to appreciate one point over here in the leaf switches, these interfaces and these interfaces. These are the interfaces which are supposed to be connected to your spine switches. So these interfaces are your uplink interfaces, and these interfaces are the interfaces which are supposed to be connected to the server. So these interfaces, you can call them to be as your access ports. And of course, using these interfaces only, our controllers are also connected. Of course, we know that we have seen that in case of our topology, our controller is connected to the leaf switch, and our leaf switches are connected to our various servers. All right, different models. So many models are available based on our requirement, how much throughput we require, how much per server bandwidth we require, and various other capabilities. These switches are for the purpose of those. Based on different versions, Cisco has given us a good scale, a good dimensioning scale, which says that how many number of leaf switches per fabric, how many number of physical ports per fabric you can use, along with how many number of spine switches. So this number of spine switches, number of leaf switches, it keeps on changing based on the version. So the best is using the Cisco data sheet. The connectivity, one more time. So one of the versions says that you can connect up to 200 access leaf switches with each 28 into 100 G access, 326 RU of space. Guys, the connectivity is humongous. So if we have, say, hundreds of leaf switches, of course, we should say no to BBB, box by box approach. We should not at all go for box by box approach to configure it. Rather than we should have one single point of configuration management. That is nothing but that is our controller. Well, this particular journey is basically focused towards this only. This course, what we are going to do is nothing but, as per Cisco, this is called as Data Center ACI implementation, DCACI. So implementation is foremost, then comes operations and troubleshooting. There is a separate course for that, but if you wish to, I will give you certain tips on operations and troubleshooting as well. Of course, if you know how to configure it properly, how to implement it, only then it makes sense to understand the operations and troubleshooting. ACI infrastructure, our leaf switches can be connected with various other network devices. They can be connected to directly, for example, to our servers, physical servers, and then virtual servers. They can be connected to the firewalls. They can be connected to the external non-ACI world, both in L2 as well as in L3. Now, the way our leaf switches are connected, right, to different devices, we call our leaf switches with different names. For example, if our leaf switch is connected to external devices, we are calling our leaf switches as border leaf switches. If our leaf switches are connected to servers, then we call our leaf switches as server leaf switches. Sometimes we also call them as Tor switches, but server leaf is more appropriate terminology, right? Well, you need not dedicate your leaf switch only for the server purpose only. You may have a leaf switch which is connected to both your servers as well as to the external non-ACI world. My dear friends, this is your non-ACI world, L2 and L3, right? So that's what this diagram is trying to tell us. Well, over here, I'm just trying to show you, I'm trying to give you a high level understanding of our leaf switch connectivity to the server. Of course, we should know it. Very, very important it is that we may have a connectivity number one, which is very popular kind of connectivity, which is called virtual port channel, VPC, virtual port channel connectivity. We have seen that, well, in case if you know what is VPC, you know that in case of VPC configured in Nexus OS, these two leaf switches, they need to be connected to each other using port channel. But ACI abstain us from doing this connectivity. No back-to-back connectivity, but ACI do not prohibit us from bundling these two physical switches and presenting both of them as one single logical entity to the downstream device over here. We have our lab wherein we will be bundling these physical switches together to create one particular logical switch. Very popular connectivity, because why is it so? Because this connectivity is not only provide us load balancing, but the resiliency as well. So very popular connectivity. We may have a connectivity where in a single leaf switch using port channel can be connected to a server. We have possibility of using one single link without port channel, and we may have a option called keeping one interface in active and one as standby. Over here, you need not use VPC. The most popular connectivity is, of course, number one. You know what? In case if you come across any Cisco ACI HLD or LLD, you will happen to see for sure Cisco or anyone who is defining it. This particular connectivity will be, these connectivities will be shown over there. Very, very important. Okay, now finally we have, as we have a limited amount of time to talk so much, I would like to give you, a glimpse of a bomb, a bill of material. Where is it? Okay, here it is. Would like you guys, when we order, right, our ACI fabric to Cisco, what we get? Number one, we get our APIC cluster, right? And cluster means you get 3 APICs in a cluster. What else you have? You know, guys, can you see something written as RAID over here? You get Cisco 12G modular RAID controller with 2 GB cache. When you purchase APIC controller, inside the APIC controller you have RAID. You should think why we have a RAID controller built right inside the APIC controller. You are going to get answer to this in the question in the sessions, you know. And when you order it, you also get 9300 series ACI spine switches, depending upon what is the size of your data center. Let me show you another data center wherein you will get 9500 series ACI spine switches and the line cards for your ACI spine switch. And you also get your ACI leaf switch, for example 93600 CD GX, how it looks like. So you have different availabilities. When it comes to your 9500, in the 9500, you know what do you get? You get something called fabric module. What is the purpose of it? That is another important learning. So this learning we will be taking care in our session. Okay, so I have been talking so much for so long. I would appreciate your questions to come in front. Guys, please let me know if you have. Okay, a humble request, guys, could you please, all of you, could you please share your email IDs? That will really help us to reach you guys. Okay, by the way, my agenda is still not over. There are a lot of things in ACI to be discussed. I would like to hand over mic to you guys if you have any question. At the same time, would request you as well to please mention your email IDs in the chat box. Thank you, guys. Thank you, Ryan, for sharing. Your email IDs will definitely help us to reach you. Thank you. Thank you all, those who are sharing. Okay, but feel absolutely free in case if you have any doubt, any question on top of your mind. It may be related to ACI. It may be related to the entire methodology. It may be related to, you know what?
Yeah, assistant
The
server. So a
yes,
controller is basically it is a server, right?
absolutely. Controller is indeed a server.
Okay, so that is only connected to our leaf switch only, right? That is integrated physically to leaf switch.
Absolutely correct, my dear friend.
Okay, so that means how that is extended till that you can say your spine. Suppose we are doing configuration, you are pushing configuration from that controller. So how that is being extended till that spine.
It's a beautiful question. Yes, our controllers are not directly connected to spine switches. So, but the configurations are not only for the leaf switches, but they are for the spine switches as well. So, the communication from the controller goes onto the spine switches using protocols. We use protocols called opflex, right? I'll tell you how this protocol works. We use protocol called COOP will tell you how this particular protocol works. So it is through the protocols that they take the traffic from the controller to leaf and to the spine. Of course, DHCP protocol also works over here. It's a very significant protocol. What is the purpose? We will be looking at into the purpose of DHCP, COOP, or Flex. These protocols are called control plane protocols. Right?
That is COOP. That is COOP, right?
COOP, OpFlex, DHCP, all these protocols, they are control plane protocols for different purposes. For example, we need to provide IP addresses to the leaf and to the spine switches. You know what? APIC controller acts as a DHCP server, and our leaf and spine switches, they are DHCP client. The client make the request, the entire DORA process, discover, offer, request, and acknowledgement happens. By the virtue of this DORA process, the IP addresses dynamically they get assigned. COOP is another protocol which stands for Console of Oracle protocol, and OpFlex is another protocol. COOP is basically to make sure that endpoints communication from leaf switches they can reach to the spine switches. OpFlex protocol ensures that the configuration files from the controller to leaf can go to our spine switches as well. I'll give you details of it because there are many protocols. VXLAN protocol is there. BGP protocol also works. ISIS protocol also works in between. We have a dedicated session on that.
Yeah, thanks.
Makes sense? Yep. Very good question. Guys, any other question you have on top of mind? Any doubts? Not only in terms of technology, but also, yeah.
As per the physical connectivity I saw in your PDF, we had to run the more copper and fiber cables for the each leaf and span switches, right?
That is right.
So is there any chances of getting the loop? Because we have to connect the number of cables to leaf from end-to-end connectivity, as per my understanding.
There is, and there are indeed chances of creating loop if you miscable it. And to mitigate that particular loop, we do have various protocols as well, which we have to configure, which we have to trigger in during each and every configuration. The loop can be caused in case if you do by mistake east to west physical connectivity between either your spine switches or between your leaf switches.
Okay.
Those are because of human errors.
Okay, got it.
Right? Good question. This is what I appreciate, and this is what I'm looking for in my sessions. All my sessions. Okay. Any other question, guys? Any basic question? You know what? None of your question can be considered to be as a silly question. Just simply don't think you will be asking silly questions. You know what? Why I'm saying? Because so many times I get this kind of feedback. Sir, we didn't ask question because other people may think that it is a silly question. No, I may be silly in answering your question, but you will not be silly in asking the question, guys. That's what my belief is. Please keep on giving your emails. Okay. Yeah, there is a certification after this particular course, which you can do, as I was telling you. After this particular course,
the language of the
was it a question or just
hello everyone?
Communication?
In this session, I'm discussing about spine and leaf network architecture.
Okay. Can you please go on mute, guys, if you're not asking question or not talking? All right. So yeah, there is a question about the certification. And by the way, you are going to get recording, those dear friends who have just joined. Whatever you have missed, you will be getting the recording of this session. So, well, about the certification, let me tell you, there is a certification called Aci ACI. Yeah, this is called Implementing Cisco Application Centric Infrastructure. Code is 300-620. After doing this particular course, you can go and give the examination. And if you look at the course details of it, we will be covering all the topics mentioned in this particular course. The certification called Data Center Application Centric Infrastructure Implementation. Right? Yes, guys. If you wish, those who have just joined, if you wish, you can share your contact number as well, besides sharing your mail IDs. And yes, we will get back to you. Your question, please. Okay. If no question, I believe you are good. If you are not still not good, then definitely you are more than welcome to ask your question. You can reach out to the coordinator anytime. If you want a one-on-one discussion with me any moment, you can reach out to the coordinator and he will connect me with you and you with me. And definitely you can ask your doubts, your questions as well.
Okay, just one more question. This
Please.
is Sarda.
Yeah.
So border leaf you told that is connected to the external, right? That means outside your campus network, right? That is internet or what kind of, yeah, WAN, yeah, any other kind of device?
Very good question. It can either be connected to your internet, right? Or to your just a single cable going to another non-ACI switch. This border leaf need not be connected to your internet, right? This is a leaf switch is called border leaf when it is connected to non-ACI fabric, right? Why this connectivity is required should be the next question. This connectivity is required for the purpose of migration. In case if you are migrating your, say, Nexus traditional network onto your ACI network, then you require this connectivity. We will be discussing about this migration scenario as well, both layer 2 migration as well as layer 3 migration. Right? And also, in case if you wish to look at into your WAN connectivity, for the purpose of WAN connectivity, which we definitely need for our multi-pod and multi-site configuration, the deployment, the configuration happens on the spine switches. So these are the spine switches which are connected to the WAN, and through the spine switches, our remote pod, they are connected, or our remote sites are connected to each other. Those configuration also we will be discussing about in this particular course. Very good question, my dear friend. Thank you so very much for asking, because sometimes it happens, you know, I may not be able to, because in the interest of time, I may not be able to answer and address so many questions, but your questions help me a lot in order to address those leftover things. And not only this, by helping yourself, you're helping others as well. So feel absolutely free. All right, then with your permission, I am going to stop recording